I love bringing old machines back to life, but to continue taking on bigger and bigger projects, I need to level up my tools. Now this old toaster oven, I've been using it for powder coating, but it can't keep up anymore. Hi, I'm Pete. Around here we rescue vintage Carnival rides and other little bits of forgotten Americana, and every single piece needs some sort of finish. A lot of times that means powder coating. This toaster oven worked fine for small brackets, but the projects on my list are getting bigger and bigger, and if I want to keep the projects rolling, I need to find a way to cure powder coat on parts this toaster oven would never hold. Space is always tight in this workshop, so I couldn't just go out and buy a big industrial oven, but I think I found the perfect compromise. This is going to be kind of a first look, because I bought this on Facebook Marketplace, and I didn't even look at it. I got to the location, we loaded it in the car. This is an electric smoker. I'm going to end up taking the entire thing apart, because I don't think that there's insulation between these two walls. But I think what I'm going to do right now is plug it in, see if what we have here works, see how hot it actually gets, and how much it smells from the previous stuff that was in here cooking. Yeah, it says it's over 400 degrees in there. I wonder if we can let it go long enough that it'll actually just stop smoking. It'd be nice if we get it hot enough that it burns itself out, but I don't think it'll get that hot. Easy. This must be easy mode. Well, we've got the smoker inside here, and I think my best bet is going to be to just take it all apart. So I think this door just lifts right off. Yep. Okay. Beautiful. I really hope it's possible to get this soot and grease out of here. I didn't exactly think that part through when I picked a used meat smoker as the basis for a powder coat oven. Okay, that's out. That was easy. Yeah, just what I thought. There's no insulation between these two walls. There it goes. Okay, well, the internet and the manufacturer all say to clean this with a mixture of water and vinegar, so that's what we're going to try.
Much later.
Well, it definitely works, but I don't know how much of that is the vinegar in the water or the just scrubbing with the Scotch-Brite pad. We are going to try a slightly more automated way of doing these little surface conditioning discs. Yep, I do believe that's going to work well. It's a lot like a floor buffer. You kind of have to lean it to get it to go the direction you want it to go, but unlike a floor buffer, it's only a 2-inch disc, so when you lean it, it takes off fast. It's looking real nice. I'm still not sure how I'm going to do the sides, though. How about a cinder block? Cinder block will hold it down and keep it spread out, but yeah, that looks like a winning combination. Cinder block was a great idea, if I do say so myself. One side to go. I may go back in and touch up the polishing by hand, but for now I'm really happy with that. This is one of the baking trays from that cabinet I got. This is perfect for this. It occurred to me that all the recommendations I read for cleaning a smoker involved continuing to keep it food safe, but this smoker's never going to see food again. I wish I would have thought of simple green sooner. So I need to build a temperature controller for this oven, and I've got this box right here. It's got some holes in it already, but I think we can make use of those. A PID temperature controller that we'll put in, and a timer, and then we have a number of selector switches for power and for the fan that we're going to be installing, and then some indicator lights. So it's going to look something like that. I just need to mark the box now so that we can cut these openings and get ready to put this stuff in. Then I have a layout drawing here. I think I'm just gonna put some spray adhesive on there, glue that right down, and then we can punch all of these spots. I'll leave links down below in the video description to all the tools and supplies I used throughout this video. Alright, I just cleaned up our workbench again in preparation of assembling this panel. This is going to be a buzzer to let us know that it's done running. So next thing I need to do is figure out a way to mount this to the oven. I think I'm going to hang it off the side of the oven. This has 2 holes that are already knocked out, so I'm just going to take advantage of those. I've got some threaded bushings that I'm going to use. That'll also give me a way to run wires into the oven. I'm doing it the way that I'm doing it because it is the way that it is. I need to make some sort of template here so I know what I'm marking. There. Clear this thing. Ah, perfect. Door still opens all the way. These bushings are threaded on the inside. I'm going to chuck them up in the lathe and clean them out to get a smooth bore so I can run wires through them. Next thing I have are these bushings, and these are going to be a sleeve over this piece. I need this to fit inside of it. Okay. Now I just need to machine them down a little bit to get them to the length I want. That goes in there. Finally getting a chance to use those larger combination wrenches I added to my collection. So that slides on there, and that slides on there. I don't know if that's going to be strong enough by itself. Maybe we'll have to put an L bracket off of it or something here, but we'll go with that for now. So I got 2 different directions I can go right now. I need to do the wiring of the electrical panel. I also need to insulate the inside of the cabinet and put this back together. All right, well, I've spent the last 2 nights wiring up this electrical panel. I've got a power cord attached to it for bench testing. This will have 220 run into it when it's on the oven.
Yeah, you're gonna make it all 220? Yeah, 220, 221, whatever it takes.
But I've got 120 hooked up right now. So I'm going to plug it in here, and you get to see what happens with me. Hopefully, no smoke. This is the power switch. This is in preheat mode. This will be in run mode. Actually, that should not be beeping in preheat. This error 4 is probably because there's no thermocouple attached to it. This will be for the fan. I'm not sure why that's doing that. That should indicate that it's done cooking. The timer times out, and so something's not quite right there. No smoke, so that's a good sign. And it's kind of pretty to look at, huh? Let me just have a look at my drawing here, see if I can't figure out what's going on. When the timer times out, contacts open, this should go back, buzzer turns on. So yeah, this needs to be gray. And I gotta get that the whole way from here. It's gonna be more complicated than before. I mean, I realize the electrons don't care what color the wire is, but I'm trying to maintain the color code here. Nobody would ever know but me. Well, now you. There's not many other mistakes I could have made that would require me to change every single wire tie in the whole panel. Let's hook the thermocouple up before we power it back up again. Looks like that should go between 9 and 10. Okay, it thinks it's 79, and it's trying to get to 221. The output is currently turned on. This should be on, but I don't see that that's lit up. Unless our minus and plus is reversed. I had two different documents that were in a disagreement over which was positive and which was negative there, so let's see if this works now. The output is on. Yeah, so now our solid state relay is also on. So that was backwards. If we turn it from preheat to run, the timer should turn on. When the timer times out, the alarm should turn on, and whether the PID is on or not, the solid state relay should turn off. Okay, that's good. Now the PID is still on, but the solid state relay should be off, which it is. Now that we've got the electrical panel done for tonight's festivities, this is the bottom of the oven, pretty well cleaned up right now, and it's got a drain hole there where I guess the juices used to come out. We're going to take that to our advantage, and I'm going to mount a fan through that hole. So the idea is this fan will come up here, and this is a convection fan from an oven. So this is going to end up going on here. Now I don't want it sitting that high. I want it down closer to the base. So we're going to make a little bit of a standoff to hold the motor. And then once that's done, we're also going to upgrade our element. This is a 2400 watt element. The oven originally had a 1500 watt element. I've got this aluminum plate here. It's kind of surplus from something else. And I've got this drilling pattern. Just stick this on here anywhere. It's not super critical. Take this over in the milling machine and run that right through there. Oh, come on. What we need here is some rubber cement thinner. I do believe I have a very rusty old can of it. I gotta get another can to transfer that over to or something. It does take it right off though. So let's put this back on. That goes on there. Tell you what we'll do. We'll stack parallels underneath, get the kind of spacing we want, and then we can just measure it. I'm using a very scientific method here in designing this part that we call TLAR. And TLAR was taught to me by a NASA engineer. TLAR is an acronym, and it stands for That Looks About Right. Okay, this would be 3/4, which would just be cutting these spacers in half. I made this back around 1995 when I was making a lot of kites. And I had to cut up a lot of carbon fiber. We have to transfer our mounting holes to this plate. Yeah. Okay, we are dangerously close to being able to put this oven together. Before putting the insulation in, I want to run some electrical wiring. I want all the wiring running down to the heating element and the fan to be contained within inside the shell of the oven. Now I have some high temperature wire. This stuff will easily withstand the temperatures of the oven when it's cooking, but I need to make a path for it. The oven has these rails. I need to go ahead and drill some holes down through them so that there is a path for the wire to run. I don't have a whole lot of room in there. I'm going to have to kind of try to drill at an angle from two sides, but I think I can do it. Thanks to our channel viewer Brian, who passed this along to us. So I've got this box of cut-off arrow shafts. I used to use these cut-offs for making custom kite fittings, and I have a lot of them left over here. I want to use these as sleeves through these holes to give me a place to run the wire. It's making a mark. I just don't know if it's doing anything as far as cutting goes. Oh, it did. Okay, that'll work. So we're going to make 1, 2, 3, 4, 5, 6. We need to make 9 of these. So I got all our tubing cut. Before I put these in, though, one last thing I want to do. I'd like to flare the edge of this out just to, I don't know. I just want to do it, right? I have a flaring tool here, and this is an interesting tool. This thing has horrible reviews on Amazon from a bunch of people who have no idea how to operate it. Let me just talk about this a little bit because it's kind of comical. First of all, people will say, well, I got this and it already had a piece in here that was flared. This thing is used, yada, yada, yada. Well, it's not used. They just tested it and they wanted you to see that they tested it. So they left that piece in there. The next thing that they complain about is this tip. They say, well, this thing's already bent. The tip is all cattywampus in there. I don't know if you can see how that rotates. If you read the description for the item, it actually says that it has an eccentric tip. And the idea is that rather than just jamming it in there and trying to flare the whole tube at once, it basically rolls around the outside, and it works a lot nicer that way. And then the final thing is that they complain about, and this one's kind of really funny. It says, well, there's these screws in this end, and there's this pin in this end. How do you get that in there without taking those screws out? Take your piece with the screws in there and just literally do that. It's not rocket science. The thing that's kind of concerning about it, though, is that anybody who would be buying a tool like this, you would think that they would have some mechanical ability, that they might be able to figure this stuff out. This is actually a very nice unit, and it's fairly inexpensive for what it is. So we're going to be using this today. Anyways, I'm ranting about something that has nothing to do with anything. I'm going to flare the ends of these, but here's the thing. These are very stiff. If I try to flare these the way they are, they're just going to crack. So I need to anneal them first. So I'm going to hit them with a torch, and then that will soften them up. We're engaged. We're running around the outside. Okay, got all these flared. I think they're going to work. It's going to give them a liberal coating of this high temp RTV and stick them in there for the night, and tomorrow we'll pull wires. It's the next day. Our silicone has set up and we can move on to the next steps. So order of operations: legs, then the bottom pan, then we can install the wiring. After the wiring, insulation and liner, and at that point we're buttoning it back up. So we're getting close here. So in case I didn't explain, 2 of these are just single large conductors that will feed the burner, and this other guy that's actually a 2 conductor that'll feed the fan. All right, that's what our inside looks like. Don't know what it's going to take to do this job, but we'll mask up here and find out. That cut's really nice. There we go. I think it might be time to invest in one of those fancy pneumatic riveters, but I don't think I'd have the room to use it in here. Nice. Working over top of this thing reminds me of those pictures from the 60s or 70s with the women out suntanning with the metal reflector in front of their faces. That's what it feels like. I'm getting cooked here. Okay, we're pretty much coming down to final assembly here. One of the things I have to do is make a spot for the thermocouple. Now my idea there is to come right through this spot, drill a hole in the inside where we can thread the thermocouple in there. All right. Cut it off there. I'm wearing these gloves because the fibers on this wire are really itchy. The other end of this needs to come up here and go into the solid state relay. And I'm going to put a fork terminal on that to put that on there with. So speaking of crimp-on terminals, I had a bit of an epiphany this week. I've been using these crimpers for a very long time. They're not the best in the world, but they're certainly far from the worst. But it seems like recently they're not doing as good a job as they used to. When I crimp down on something, the wire pulls out. And then I realized the problem occurred when I shifted to using crimp-on terminals that have heat shrink tubing on them. These don't crimp down enough because the heat shrink tubing is much thinner. And after a little bit of research, I realized that there's special jaws you're supposed to use. We're going to get these swapped out, and this will be the first time I actually try using them to see if it does the job it's supposed to do. I'm really curious to see if this works. There's no reason for it not to work. I just can't believe it took me so long to realize. So much better. That'll do, pig. That'll do. I am glad I'm wearing these gloves. So yeah, this guy will go up here, this guy will go down here. Now the Element doesn't use that. It has a special high temperature crimp-on connector. Okay, next thing I need to do is create some racks that I can hang parts from. Now originally, this smoker had these rails on the side that you could slide your trays in on. The problem is that these were mounted way down here. I want to be able to install a rack all the way at the very top so that we can use it to hook stuff from and, you know, really be able to do large pieces in here. So I'm going to reuse their original side rails. I'm just going to mount them up higher than they used to be. And to do that, I'm going to use that riv nut tool that we picked up when we were up in New York. I think that's probably going to be the easiest way to do it. The original holes that rail was in, I'm just going to put some rivets in there to fill the holes. There's actually support rails behind, so that'll help stiffen the whole cabinet up a lot more. So those stainless steel ones are much harder to squeeze than the aluminum ones. Wow. Yep, and that's where we'll hang our parts from. And if we had small stuff, we could put another rack in. Alright, let's see what we can do about making up this electrical cable. Actually have instructions on the inside of the box. There you go. What I'm looking for here is, this has a gray insert. There's also a red and a black. I just want to make sure I use the right insert for the size cable I have. 650, 550 to 875. You're supposed to use gray with what's already in there, so we're good. That can feed through. This thing is wicked sharp when it's got a fresh blade, and it's not currently wicked sharp. These get stripped back 5/8 of an inch. Seems kind of a bit excessive, really. We can put this back together. Okay. It's powered up. Okay. This should be our fan. Yeah, that heating element is on. It's currently shooting for 221. Do some reading here on how to set this the way I want it to be set, but I think it's fairly straightforward. It's just finding the parameters and setting them. Okay, after a test run, the fan has failed. And this was something I was a little concerned about, but I figured it is a convection oven fan and it's designed to work in something like that, but something has failed and there's a lot more play in the shaft now than there was. Let's take it apart and see what we find. Is it because the whole center of this motor is plastic? This motor is originally intended to operate with the shaft horizontally, and I'm running it with the shaft vertically, which means the whole weight of that rotor is having gravity pull it down. I'm going to put all 3 thrust washers on the bottom, since we're using it in a vertical orientation. And then I'm just going to put it back together, cross our fingers, and this time I will put in the insulation, and hopefully with all of that we won't run into a problem. And there, around 398, we should see that green light turn on to tell us we're kind of in the ballpark. Idea there is I can see that from across the room, maybe not be able to read that. Alright, there's our green light. We've hit 398. Alright, so let's go into timer mode now.
10 minutes later.
Okay, so that is that. I can open this to let it cool down. But I have to turn the whole thing off. There's no way to just leave the fan running. This is our 2-position switch that gives us preheat and run. I'm going to swap that out for a 3-position switch. So that will give us preheat, and then in the middle will be stop, and the other end will be run again, just like it is now. Okay, we've got this plugged in. We'll turn it on. Power's on, so this is on. If I turn this to preheat, heating element should start warming up. I can feel the heat. Turn the fan on. That works. Now let's pretend that it's gotten up to temperature. So we're going to turn it from preheat over to run. So now the temperature controller is still doing its thing, but it's going through the timer. Timer's set for 10 minutes. And we can change that to be whatever we want it to be, depending on what the powder requires. So now when this gets up to temperature, the green light should come on. And at the end, when all is said and done, the timer times out, the buzzer should turn on. That will turn off the heating element, but the buzzer is going to continue to just keep buzzing to tell us it's done, it's done, it's done. So that's where we'll come over here and put it into the stop position. The fan can still run. The temperature controller is no longer hooked to the heating element, so the heating element can cool down. And it'll just sit there running forever. And this just gives us a pilot light to let us know, oh, hey, we've left this power switch on. That looks a little better. So I didn't have anything large ready to go in the oven, but I figured you'd be pretty upset if I didn't at least show you it doing something. So I ran one of my steering wheels through, and because I got so much grief for powder coating aluminum steering wheel silver, we went with red this time. And as always, if you want to follow along with this project, click that link to the left and come along for the ride.